Greetings everyone. This is Harsh from Team Neuro, and today we will be presenting a paper called titled "A Simple Recipe for Multilingual Grammatical Error Correction." So, what was the motivation behind choosing this paper? As we know, we have Grammarly for English language, which is well widely available, but not for Hindi. There are no tools like Grammarly for Hindi, and this creates a gap because many writers who may want to express their thoughts in their native language do not have access to such tools. And the Grammarly for Hindi, if we consider it as a result, can be assistant tool to non-native learners of Hindi in acquiring proper grammar. This will also invite new generation of people in learning indigenous writing culture as well as speaking culture. Related works. So the related works that we have considered while learning this paper was detection and correction of grammatical errors in Hindi language using hybrid approach by M. Mittal, which was published in 2019. So there are basically three techniques used for grammatical error correction, which included rule-based, a statistics-based, and a syntax-based. This paper uses a hybrid approach where some components like pure stagger and statistical approach correction error system has been developed using a rule-based approach. In this paper, somehow no neural network is used. Instead, n-gram models like bigrams and trigrams are utilized in this paper in making detection and correction procedures. Why this paper is different than existing papers. So the first reason is scaling and large multilingual models. The authors of this paper have utilized MT5 model, which consists of 101 languages. And in this paper specifically, 4 languages have been tested, namely English, Czech, German, and Russian. Uh, this paper has also introduced C-lang text corpus, which is a cleaner version of Lang 8. Third USP of this paper is language agnostic model. It introduces language agnostic model, which is basically a language model which is not dependent on any language. It can be implemented on any language. And fourth, it provides a simplified training pipeline. So I'll this presentation to Madhav.
So methodology. The the first task is to select a model. So authors select MT5, which is a multilingual version of T5, and it is a transformer encoder decoder model, which has been shown to achieve a state of art result on wide range of NLG tasks. MT5 prepare pre-training on 101 languages on MC4 corpus, and MT5 pre-training objective is based on span prediction task, and it comes in various variant, but author selected two variant with 600 million parameter and the 30 XSL version with 13 billion parameter. Now say step 2. The second step is GEC pre-training. Why it is required? Because the MT5 is spanning the spanning prediction objective of MT5 does not enable the model to perform GEC task. And another limiting constraint is that MT5 has been trained on paragraph, not sentences. So author split the all paragraph into sentences and use this technique called language agnostic corruption operations. It is a technique just doing operations on sentences by dropping some tokens, swapping some tokens and character, and like case modification. And they keep 2% example uncorrupted because sometimes the sentence would be also the correct. Next. And then step 3 is fine tuning. The fine tuning task is done for 4 languages: English, Czech, German, and Russian. And they use their respective dataset for training for particular languages. So author they drive 3 experiments. They do 3 experiments. The first one is mixing GEC pre-training data with fine-tuning data. Second is mixing pre-training and fine-tuning examples but annotating them with different prefixes. And the third one, first use GEC pre-training until convergence and then fine-tuning. It is the most computationally expensive approach, but it also gave us the best result. And then they use this model to create a CLang database, which is a clean version of Lang8 database. Next, the contributions. So this paper gives a major three contribution. First one is language agnostic pre-training method. The problem is existing synthetic data generation required language specific resources. This method provides simple text correction that works for all languages, like a drop tokens, swap tokens, drop characters, swap characters. And as we said, they keep 2% example uncorrupted to teach model that inputs can be grammatically correct. And the second contribution is the model scaling analysis. Author shows that effect of model size scaling from base model 600 million parameters to XSL 11 billion parameters, and they find that large models outperform smaller ones. And the third one is release the CLang8 dataset, a corrected, cleaned version of the widely used but noisy Lang8 corpus. Next. Now the results. So they evaluated on 4 languages, as I said. For English, they evaluated on standard benchmark from CNN LL14 and the BE test. For other languages, they use the test and development set associated with their training data. So as you can see, all the results of all the languages. These results are not good for English because it had high variance and the training was overfitting very quickly. So they further refine their approach. And next. So as previously that they created a CLang8 database from the Lang8 corpus, and CLang8 is the clean version of Lang8 corpus, and they created 2 versions of CLang8. And you can see in the slide that these are the parameters that is shown. The CLang8 and CLang8 as different versions of CLang8. Next. And this is the last result they got by using this CLang8 database to train to fine tuning, and they achieve a good result and achieve a state of art. And these are the results for English. Next. And these are the results for other languages like German and Russian. Next. Now I will pass on to hers.
So we will discuss about future work. So for the future work, the authors have proposed that creating better data sets with intentional errors, which can be beneficial for creating a better neural network. And for second, they have proposed that training and testing on localized dialects of Hindi, which will also expand the usage of the model. This can be achieved by using pre-training the MT5 model on Hindi language by GC training. Other than that, we can further improve the neural network based models for grammatical error correction by swapping or deletion or removal of stop words, as previously discussed by Madhav. So what novelty can be extended from the existing work? So building on these groups, we can suggest a bigram and trigram statistical model for real-time error correction similar to Grammarly for Hindi. And we can apply MT5 multilingual model specifically for Hindi data, and we can train them pre-train them to be set to predict words for Hindi language. Uh, we can use a morphological analyzer from TDIL project, which is made by Ministry of Ministry of Education and Information Technology, which is specifically trained on Hindi and Punjabi, with an accuracy of 87.64, which for error detection and correction, and creating a clean Hindi dataset by model distillation. We can create a cleaner version of Hindi dataset by pre-training on it. So now we will discuss the timeline as proposed by our group. In the week 1, we will be selecting the model for training. Week 2, we will be collecting data for Hindi model. And in week 3, we will be introducing errors in our collected data and tagging the types of error in the data. Week 4, we will be providing recommendations to resolve error once error has been identified. Week 5 is testing phase, and week 6 will be our refining phase. All these timelines will be in accordance with our mentor. We will be discussing it with our mentor as well. Thank you.